Yes, welcome you all for another a very interesting and beautiful presentation on properties of joint probability density function. This is the lecture number 8, in which we are going to see very important properties of joint probability density function, that is f of small f of x of y, in bracket you can write xy. Clear? So the joint probability density function is represented by f of xy, small f of xy. Remember that. If you recall from the last presentation, we have seen that the joint distribution function, or in general, I can tell you that for any random variable x or y, as you know already, the random variables can be represented by the capital case letters, right? The random variables are represented or denoted by capital case letters, either X or capital Y or capital Z, is it not? And their possible outcome values are represented by with small case letters. If you take the capital X as a random variable, then consider its possible outcome values are represented by small case letters small x. Similarly, for y, the possible outcome values are considered with small y. Similarly, for z, it is small z. Clear? And we have seen in the last presentation that, right? So the distribution function, what is the distribution function? So distribution function is nothing but, or otherwise, for any random variable x, let us say, if I consider random variable x with respect to any random variable, we have two types of functions. For your easy okay, remembrance, or for your easy quick reference, you can remember like this. For any random variable x, okay, or any random variable either x or y or z, whatever it is, so it has two types of functions. One is capital PDF, means probability distribution function, and the second is probability density function. There is a lot of difference between capital PDF and then small PDF. It is a probability distribution function, nothing but it is capital F of x, in bracket you can write small x. It is capital F suffix capital X, means it is the distribution function of random variable x, and in the bracket small x is nothing but the possible outcome values of random variable x. Clear? And if you see here, this is what the PDF, nothing but the probability density function. I am repeatedly repeating the sentence for your quick and for your I mean easy remembrance of these terminologies. Never confuse. It is probability distribution function, or simply distribution function, that is denoted by with the capital F, whereas probability density function is denoted with a small f of x. This is capital F of x and this is the small f of x. These are the two types of functions that any random variable can have, right? One is the capital PDF, and remember that this PDF can also be called as CDF also. Either you can write capital PDF or otherwise capital CDF. What is CDF? It is cumulative. Your CDF is nothing but cumulative. What is cumulative distribution? Cumulative distribution function. Cumulative distribution function. So capital PDF can also be called as CDF. CDF stands for cumulative distribution function, right? So that is what your capital F of x, and this is the small f of x, right? Therefore, for any random variable x, these two kinds of functions will be okay, available. Okay, means or exist otherwise. PDF, capital PDF and a small PDF, right? This is with respect to a single random variable, right? Now we are discussing actually with respect to the joint probability. Joint in the sense we must need two random variables, and those random variables what we are calling as x and y, right? So if you write the joint distribution function, that is capital F of x comma y in bracket, if you write small x comma y, this is equal to probability of the event, that is joint event, you can say x is less than or equal to small x, comma, as well as capital Y is less than or equal to small y, right? So what is this actually? This is the joint event actually. The quantity whatever is there within the bracket is called, if you write in this way, this is called joint event. For this joint event, if you take the probability, then the whole probability of the joint event is called as the joint distribution function. This is the joint distribution function. This is the definition. Remember that I already explained you this in the last presentation. Remember that this is called the joint distribution function of random variables x and y. Joint distribution. And similarly, once if you know the joint distribution, then the calculation of the density is also very easy. The joint density function, that is what here, joint density, joint probability density, or simply you can write joint density. So the joint density now is given as small f of x comma y, in bracket you can write x comma y. This is nothing but it is the simply the derivative of the distribution function. So as it is a two-dimensional, otherwise it is a joint, otherwise x and y, okay, then definitely you should have dou square by dou x into dou y of capital F of xy in bracket, right, x comma y. This is what the definition of a your joint density function. Remember that. So this is what the joint density function. So small f of xy is nothing but the derivative of the distribution function. Therefore, the derivative of distribution function is nothing but your density function. And in the last presentation, we have also seen some of the properties of this distribution function. And now we will see some of the properties of this density function. What are the properties that the density function satisfies? The joint density function rather than. Let us see one by one. There are few important properties are there based on which you will expect the questions in your competitive examinations, right? The first and foremost property is that the property number one. The property number one. So the property number one states that the joint probability density function f of xy in bracket x comma y is must be greater than or equal to 0. That is the first property. Clear? F of xy is greater than or equal to 0. What is it means? What is it means that the joint PDF is means that is a non-negative function. What is this? It is a non-negative function. What does it mean? Means that it should not be negative. That is what non-negative means. It must be a positive one. It must be a positive one, either equal to 0 or otherwise it is greater than equal to 0, but it should not be negative. It is a non-negative function. That is the first property. What is this actually? Joint PDF. This is called joint probability density function must be a non-zero function. It is a non-negative, we can call non-negative, non-negative. That is the first condition. Now Very, very important property is the second property. So this means this represents, I mean, this gives, if you take the integrals minus infinity to plus infinite, as well as it is double integrals actually, minus infinity to plus infinity, small f of x comma y, in bracket if you write x comma y, dx into dy must be equal to 1. So here the first integral corresponds to can take as for x, and the second can be it is for y is equal to, you can take no problem. So the first integration it is for x, or otherwise y is no problem, you can take it is for y or you can take for x, don't worry, nothing wrong in that. So as we have two random variables, so this is with respect to random variable x, with respect to random variable x, and this is the joint PDF of random variable x and y, and it is integrated with dx and dy. Then if you take this integration of the density function with these limitations, you should have the value 1. This is the very, very important condition. This is the very, very important condition. What does it says? What does it mean? This indicates that by taking the integration, you are evaluating the area under the curve. That is the meaning of the limitation. What do we by the integration? What is the meaning of the integration? Integration is nothing but you are evaluating certain function, or nothing but here it is the PDF density function. This density function is we are evaluating within the intervals. Means for x limitations minus into plus infinite, for y it is minus into plus infinite. Under these limitations, once you evaluate this function, and it should have the value equal to 1. Means the area under this density function must be unity. It must be unity. That is the very, very important property of a joint density function. Once if the area under the curve, that is called area under the curve, and which is bounded by these limitations. That is the meaning of it actually. The area under the curve of the area of this f of xy, this function covered or bounded, you can say, within these limitations of x and y must be equal to unity. Then only this is called a valid density function. If this density function satisfies this condition, this property, then you can say that the given density function is a valid density function. Remember that in your regular BTech examinations or university college examinations, as well as in GATE or otherwise even in UPSC examinations or any other technical competitive examinations, if the question is given based on this, definitely this question is very, very, very important. What is the question? The density function will be given to you. Means either a single probability density function with respect to single random variable, or otherwise sometimes the joint PDF is also given. Means f of xy will be given, and you will be asked that find out whether the given density function is a valid one or not. Let us see now, after finishing these properties, I will explain you one problem for you, so that you definitely will enjoy how easy it is, and how easy to calculate to determine whether the validity of the I mean density function. Clear? So this is what actually the second property, second property of this density function. And now let us see the third function, third property. Let us see the third property of the density function. Let us see. So the third property gives like this. Say that from the definition you can say that, as we have seen, the third property. What is the third property? Means that as you know the definition of the distribution function, or otherwise directly I can tell you that is small the f of x comma y, and then x comma y, this is equal to dou square x by dou x into dou y of sorry, this is f of x comma y xy. This is definitely from the definition of the density function that you can take as the third property, or otherwise sometimes it will be given that the PDF will be given to you, right? The small PDF will be given to you, and from that you will be asked to determine the f of xy. In that case, what we need to do? Clearly observe this. Yeah, you know that if capital F of x is given, means distribution is given, simply if you take the derivative or differentiation of the distribution function, you will get the density function, means small f will be obtained. Whereas in the reverse case, say for example, if small f is given, then what we need to do? Just integration, that's it, integral of this. If you take the integration of this small f, then you will be obtain the capital F of xy, capital F of xy. Clear? That is what the meaning actually. That is what. So directly you can take the definition of the PDF as a third property. Nothing wrong in that. You can take it as a third property. And then now coming to the fourth property actually. What you know? So for example, if you take the probability of the joint event, the probability of the joint event of x and y, and again the random variable x is lying in between x1 is less than or equal to capital X is less than or equal to small x2, comma, understood? Means this is the probability of the joint event, and the joint event of x and y means the random variable x and random variable y, and again the random variable x has two limitations, means x1 to x2. Similarly, the small y1 is less than or equal to capital Y is less than or equal to y2. If it is given like this, if you are required to calculate the probability of a joint event which is defined in this case in this way, then this whole probability is equal to what you can write, this is nothing but, so like this, again the same what we have seen, this is nothing but it is x1 to x2. Similarly, it is y1 to y2 and f of xy comma xy, and definitely it is dx comma dy. That is what the meaning of it. Clear? So means that what? So I already told you that based on the previous property, means density function will be given and you will be asked to find out whether the given density is a valid one or not. That is one type of questions you will expect based on the properties. The second very important question is that sometimes the probability will be given, means the x limitations will be given like this. Maybe capital X is varied from 1 to 2 or 0 to 1 or whatever the probability will be given. So then, and the density function will also given, then for these limitations you need to find the probability. So probability of this event can be equivalently written in this way. Then simply, so probability of this joint event is equal to this much. Therefore you apply the limitations in this and joint PDF is given to you. Evaluate this integral. Finally you will get certain value. That value itself is the answer for that. Means the probability of the joint event comes here after evaluating this integration. Clear? Clear? So this is what the fourth property. Now the very another important property of the joint probability density function is that very important actually. The fifth property, right? Right? The fifth property, let us say, what it will be given, so this gives like something like this. So f of x of x is equal to minus infinity to plus infinity f of x comma y. Just note down, I will explain you what is the meaning of it actually. So this is nothing but dy. right? So if the joint PDF is given, clearly listen, if the joint PDF is given, from this joint PDF, sometimes we need to find out the individual PDF, means individual PDF of random variable x itself. So the joint PDF is given to you. From that, you will be asked to find out this fx of x. Then, in order to find out the fx of x from the giant PDF, this is the formula actually. Means you must consider the integration with respect to y actually. These are the y values. For finding f of x value, remember that, do not confuse here. In order to find out the PDF with respect to x, PDF of x is equal to, you must take the integral with respect to y and take the joint PDF, integrate this function with respect to dy. In this case, what is this fx of x is known, you know, this is called marginal. This is called marginal PDF. Marginal PDF of random variable, I can simply say RV, random variable of x. This is called marginal PDF, marginal probability density function of random variable x actually, right? And similarly, if you write f y of y can also be in the same manner, you can write. This is same, minus infinity to plus infinity. Take the joint PDF, means f of x y, right? F of x comma y, in bracket you can write x comma y, giant PDF. If you take y, you must consider the limits of x actually. Take the x values here, then definitely it should be integrated with respect to dx. This is called the marginal. This is called f of this fy of f is called as marginal. What you know? Marginal PDF means probability density function of random variable y. These are the few important properties of giant PDF. I think you have enjoyed this session, this presentation otherwise, and we will see some very important examples based on these properties. We have seen the definition of a giant PDF, and a giant PDF nothing but probability distribution function as well as density function, and we have seen certain properties, right? I think you enjoyed this. I hope that you understood well, and we will see the rest and continuation part of it into the next presentation, right? Thanks for watching this video, and we'll meet in the next presentation. Until that, have a beautiful day.